Okay, brief introduction to roots. I'll erase all this stuff here. Now, on a previous video, I had mentioned this, but I want to mention it again. The ancient Babylonians in around 1700 BC, to them, numbers weren't, I wasn't around then, but they were, shall we say, distrustful of what we think of as numbers or symbols. They wanted to be able to draw something. And the Greeks during the classical period of Greek mathematics felt the same way. So, for example, a number was a length. So let's say that's 8. And let me make this into a square. So I took a length and I made it into a square, let's say an 8 by 8 square. And what I've done is I've squared the number, and that's why we read this 8 squared. I mean, it's literally why we read it that way. And if we run this in reverse, I could say, for example, I'm thinking of a square whose area is 49. What number gave birth to that square? And if something gave birth to you, it's your roots. And we're talking about a square, and that's where this term, the symbol came later, but the term square root came from. So what's the square root of 49? It's asking you what number, when you make it into a square, is the area of 49, and the answer is 7. And that concept, I think, is fairly straightforward, and it's fairly simple. Nothing astounding, and that's good. I mean, you don't want to be overly riddled with anxiety when you see this particular symbol right here. Square root of, say, 81 is 9. Now, I'm going to connect this with the Pythagorean theorem, but the Pythagorean theorem, it wasn't known in its modern form until Pythagoras, but for example, the fact that if you have a right triangle and one of the legs is 3 and one is 4 and the hypotenuse is 5, it's a right triangle, and 3 squared plus 4 squared equals 5 squared. That was known at least as long ago as to the ancient Egyptians, going back to about 2000 BC. We could prove the Pythagorean theorem in 100 different ways. In fact, I used to have a book called 101 Proofs of the Pythagorean Theorem. I don't know, I loaned it out, never got it back. We could prove it physically. You can't really prove it physically, but you could demonstrate that it's probably true physically. It's used in construction, it's used in mathematics. I mean, it's just, let's just accept right now that the Pythagorean theorem is true. So a squared plus b squared equals c squared. And I want you to consider this triangle. Actually, famous triangle, very important triangle. Doesn't seem like much, and yet it is. And the question I have for you is, what is the length of this side? The first thing to be addressed or established is what I'm about to do right now, I'm going to ask you to do something similar to it on the next test. So it may not seem like this is a testable sort of thing right away, but you'll see it is. So the question is, what is L? I mean, the first question should be, is it real, or is there even such a thing? And I think that we could probably agree that if this length of 1 and that length of 1 is real, then this length going across here is real. So I think they have equivalent, their reality is equivalent, at least. What could you say about L if you knew nothing about geometry, if you never heard the Pythagorean theorem? Well, one thing you could say is this. Consider drawing a square around like this. And I think it's fairly obvious that, just by looking at it, just by inspection, that whatever L is less than 2. Because after all, why do people cut across? Why do people cut across the diagonal, say, of a courtyard? And it's because it's a shorter distance. And it is. And so I think this is a fairly obvious thing. And not only that, but L is greater than 1. So without a doubt, I think without a doubt, you could say that whatever L is, it's more than 1 and it's less than 2. So it's, again, some number greater than 1, less than 2. Just keep that in mind. Fix that in your mind. Let me erase this person here. And what I'd like you to do, or what I'd like to do, is apply the Pythagorean theorem to this triangle. So we have L squared is equal to 1 squared plus 1 squared. So L squared is equal to, that's 1, add them together, 2. Oh, hey, time out. Think about this for a second. No hurry. I would like you to answer the following question, and I would like you to have as great a certainty as you could possibly have. What's the square root of 7 squared? Be sure. Yes, you're correct. This is 7. What's the square root of 8 squared? Think about it. Pause the video if necessary. But I want you to be really sure that you know what the answer is. And the answer is 8. Oh, let's flip it around a little bit. How about if we took the square root of 49 and we squared that? And think about that for a minute. Pause the video if necessary. That's 7. I think you can see that if you take the square root of star squared, you get star. So squares and square roots, they are inverse to each other. They undo each other. Oh, and similarly, if we took the square root of star and we squared it, we would get star. Now, these follow from the definition of what a square root is. Somewhere along the way, I'd written that down but the square root of A is equal to B means, there's other ways to put this, is equivalent to, or if and only if, but this means B squared equals A. And that's the formal definition of a square root. And after all, you knew the square root of 49 is 7. And how come you knew the square root of 49 is 7? Because you know 7 squared is 49. I mean, that's really the whole idea of square roots. Okay, now, back to this equation up here. We need these concepts here, but I don't need to have them written down. You can add, subtract, divide, and multiply the same thing to both sides of an equation. I want to throw something new in here. And the new thing is we can square root both sides of an equation. So I want to square root both sides of this equation. Now, according to what I just said, that's L. And this is the square root of 2. And here is the real question. What is square root of 2? First off, is there such a thing? Yes. Look, you're looking at it right there. It's that length. It's real. I don't know if I should address this right now, but I will. I've actually had people tell me it goes on forever. No, time out. Look. That length, it doesn't go on forever. So, in fact, we just agreed a minute ago, whatever the square root of 2 is, it's greater than 1, but it's less than 2. And if it's less than 2, it does not go on forever. So it is a number, and it is real, and it's something in between 1 and 2. Okay. I know the temptation is to use your calculator. Please don't. That's exactly what you shouldn't do right now. It'll take you down the wrong road. Okay. I'm thinking of a number. We're calling it the square root of 2. It's between 1 and 2. Okay, take a guess. If you had to guess at a number, I'm thinking of a number between 1 and 2. Guess what number I'm thinking of. There's an infinite number of numbers you could use as your guess, but I mean, and you don't have to use this one, but I don't know. Something costs more than $1 and less than $2. What do you think it costs? $1.50, $1.50. It's a pretty good place to start. So my first conjecture, my first guess, is that the square root of 2, I'm going to put a question mark up here, is equal to 1.5. Now we get to find out if you really understand what square roots mean. Let me go back to this again. I don't need to beat that horse, as they say. Sounds like a terrible thing to do. The square root of 49 is 7. And why do you know that? Why? How do you know that that is true? And the reason is because 7 times 7 is 49. That is the entire reason. So if this were true, then 1.5 squared should equal 2. Well, what is 1.5 squared? Now, I always do this in my classes. Say we have 30 people in a room. I ask, what is 1.5 squared? I walk around the room. I am lucky if I get 10% to get it right, which is an amazing thing. Because that just means take 1 and 1/2 and multiply it by 1 and 1/2. And this is where fractions keep just killing people in math. And I mean, really, there's some point where you just have to get over that, and you just have to learn how to do fractions. And then you can stop being so, and I'm not saying they are, because I don't know, but once you really learn to deal with fractions, wow, just so many things become clear. So what is 1.5 squared? 9/4, which is 2 1/4. Now I was hoping it would be 2, but it's not. Okay, so my first guess was wrong. It's a little bit too big. So what do I know now? I know that the square root of 2 is between 1 and 1.5. So I still don't know what it is. I know it's real. I'm looking at it. But now I know it's between 1 and 1.5. So what might be your next guess? Well, you could guess all kinds of things. 1 1/3, 1.1. But, I think 1 1/4. Hey, it costs more than $1 and less than $1.50. My next guess would probably be, but again, you can do something else. But say 1 1/4. How do we check this? We have to square 1 1/4, which is 25/16 or 1 9/16. Not a bad guess, but it's too little. So whatever square root of 2 is, I know now it's between 1 1/4 and 1.5. Hey, not bad. We're closing in on it. More than 1 1/4, less than 1.5. What would be a next good guess? And my next good guess, this is another way where I can find out how comfortable people are with fractions. I can't resist. I got to do this. Look, here's 1, here's 2. What's in the middle? 1.5. 1 1/4, 1 3/4. There's 1 1/4, 1.5. What's right in the middle? I don't have to use the number right in the middle, but it's kind of convenient. Well, that would involve the 8s, and it's 1 3/8. So my next guess, square root of 2, put a question mark, is at 1 3/8. Now, something bad is going to happen here. Here, let's go ahead and do it. What's 1 3/8 squared? Well, right, that's 11/8 squared, so it's 121/64, and that's 1 and I think 57/64. What's the bad thing that's happening? Yuck. The numbers are starting to get a little worse. They're really, really easy, but now, not the end of the world, but uh-oh, I already have a number over 100. Now, that's pretty close to 2. Pretty darn close, but it's not right. So 1 3/8 is too small, 1.5 is too big. Our next guess, I would probably use something in terms of, well, you don't have to, but I would use 16ths. That's 6/16. That's 8/16, so 1 7/16. But the numbers will start to get bad, and they'll start to get bad really fast. 16ths, 32nds, 64ths, 128ths, 256, so on and so forth. And what we would find is we would get extremely close. What is the square root of 2? It's the number, when you square it, you get 2. So our guess is we would like, ideally, that when we square our guess, we get 2, and then we would have found it. But what you would find, and I suggest try this a few more times, it doesn't work. Close, but doesn't work. At this point, I usually say bust out a calculator. Now, this really depends on the kind of calculator you have. So, hey, if you have a calculator on your cell phone, try it right now. Here, I don't have mine, so I'm going to make up something right now because I don't even feel like walking out of the room and getting my cell phone. But if I took my cell phone and I typed in square root of 2, it would say 1.414 and a bunch of other things. I don't know. I'd have to sit down and calculate that out. I don't memorize. Is that correct? Try multiplying that by itself, not with the calculator. If the calculator is trying to fool you or lying to you, it'll lie to cover its tracks. And let's say this went out to a whole bunch of digits, and the final digit, let's just say, was, doesn't really matter, was a 2. If you multiply that by itself, the good old-fashioned way, you don't have to do the whole thing. 2 times 2 is 4. There's nothing to carry there, but blah, 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 0, blah, blah, blah. Doesn't really matter what it is, but when you add all those up, you're not going to get 2. What's my point? Whatever your calculator said is wrong. And most people say, well, it's really close. Hey, what if you bought a calculator, brand new? I don't know, you went to the store and you bought a calculator, brand new. You type in 2 plus 3, and it said 4.9999574. I mean, how would you feel about that calculator? I would throw it in the garbage or take it back. I don't know. It's no good. Someone could say it's close, and I'd say, I'll tell you what, I'll let you know when I want close. I want the actual correct answer. I want the right answer. Not close, but the right answer. So the question still remains, what is the square root of 2? Is it real? Yes. You're looking at it. Does it go on forever? Absolutely not. I mean, look, there it is, that picture. That line is the length of the square root of 2. It does, sorry, at hyper, because I cannot tell you how many people tell me it goes on forever. No, it doesn't. But here's the deal. I'm going to state a fact right now. I'm not going to prove it because it probably won't make you feel any better about it. The square root of 2 is a number. It is real. It does not go on forever. But it is not a fraction. It is a different kind of number. And this was first discovered by a student of Pythagoras. I don't know his name. And he proved that the square root of 2 is not a fraction. Now, the more ancient name for fractions is a rational number. Well, if you're not being rational, you're being irrational. And that's why this is called an irrational number. This bothered the Greeks. In fact, as the story goes, Pythagoras gathered his buddies. They actually were called the Pythagoreans. They gathered his buddies together and they chucked him over a cliff. Don't know if that's true or not, but it makes a good story. Now, some of you may have a calculator. When you type in the square root of 2 and you press equals, this is what it says. If you have one of those calculators, the calculator actually gave you the correct answer. It gave you the correct answer. Try this. Take any calculator and type in the number 5 and press equals. It'll say 5. Type in the number 9 and press equals. It'll say 9. How come it says this? Because 9 equals 9. It really does. It doesn't equal anything else. That's really what it equals. And 5 really equals 5. And the square root of 2 really equals square root of 2. I mean, I can show it to you right there. That's the square root of 2, that length. There's no other way to write square root of 2. I haven't proved that. If you want, you can just Google proof square root of 2. But it's the kind of proof it probably won't make you feel better about the whole thing, and it might make you feel worse. So that's why I'm skipping the proof of that right now. Pi is another famous irrational number, and I'll talk about that another time. Does pi go on forever? No. A lot of people go crazy when you say that, but it doesn't. Not because I said so, because it really doesn't. But it's irrational. So it doesn't want to be written like a fraction, or it can't be written like a fraction. Now, the square root of 2 can be written as a decimal, but it's an infinitely non-repeating decimal. There's no repeating patterns to it. Well, I mean, I should probably get a little more specific about what that means, but for right now, it's a non-repeating decimal that takes an infinite number of digits to write it out. It's like a person's name with an infinite number of letters, but that doesn't mean this goes on forever, because it doesn't. It just doesn't want to be written. It doesn't want to be written like a decimal. It doesn't want to be written like a fraction. And that's why the more modern style calculators, you can get one for $10, but any more modern current up-to-date calculator, if you type in the square root of 2 and hit equals, it'll say square root of 2. And then it can give you an approximation. A lot of times you hit shift and equals or whatever. There's other ways to do it, but it'll give you the decimal approximation. Now we're going to be dealing with these irrational numbers. I mean, they're not they do make sense. They're not irrational in the sense of not being rational, but that's what they're called. The name stuck, and I don't have a problem with it really. I'm so used to it now. Hey, what's the square root of 0? 0. What's the square root of 1? 1. What's the square root of 2? You're looking at it. Square root of 2. That's it. Square root of 3. That's it. Square root of 4. Hey, that's a nice one too. Square root of 5. Square root of 5. Square root of 6. Square root of 6. Square root of 7. Square root of 7. Square root of 8. Square root of 8. Square root of 9. Oh, that's a nice one. 3. There aren't many nice ones, and they get farther and fewer between. It's just something you get used to. Now we're going to be dealing with these numbers, and they have properties. But for this video, I just wanted to introduce the idea of what is an irrational number. It's a number which is not a rational number. I didn't prove it, but hopefully I made it a little bit plausible by looking at this picture. And if you're ever up by Mesa College, the Math and Science building, and you're wandering around outside, there are these diagrams etched into the concrete or inlaid with, I don't know what it is, stainless steel or aluminum. And one of them looks like this. Well, there's actually, look, there's no numbers on it. They could have, but okay, there's no numbers on it. And I honestly don't remember if there's a right angle or not, but it's assumed that that's a right angle. And then you draw another triangle like this, where these two links are the same. It probably doesn't look the way I drew it. So let me just put a 1 and a 1 there and there, and then another one like this. And that's a right angle, and that's a right angle. There's a 1, and another 1, and not a very good diagram. Much better diagram in the concrete. And as I recall, this is called the spiral of Archimedes. I feel like with Google, I guess me too, check all these things to make sure I remember this properly. But if we use the Pythagorean theorem, you'll see this is the square root of 2, square root of 3, square root of 4, otherwise known as 2, square root of 5, and you can continue around here. So if someone said, I would like to see the square root of 5, I don't believe it's real, or I'm not sure what you're talking about. Right there, that's the square root of 5. Literally that length. And you can see it engraved in concrete. It's real. It doesn't go on forever. I'll just state this as a fact right now without any proof, but if it ain't nice, it is what it is. What do I mean by that? Well, the square root of 5 is the square root of 5. Because the square root of 5 is not the square of any whole number. Obviously, 2 times 2 is 4, not enough. 3 times 3 is 9. Oops, went too far. So, whatever the square root of 5 is, it has to be between 2 and 3. So I'm just stating right now is a fact. It's actually a theorem that you'd have to prove, but the square root of 5 is equal to the square root of 5, and there's no other way to write it. That's enough for this video, and now we're going to plow ahead on into chapter 8.